These bird faces, or at least what I think look like birds, are being generated by my computer. The emotion, you can see here labeled in green, is also being generated by an artificial intelligence algorithm that knows nothing else but faces just like this and the emotions that go with them. This algorithm, which is called a neural network, learned to classify the faces as happy, sad, and other emotions using data that I gave it. This data is from hundreds of faces that real people looked at and classified using this web page here. I collected more than 850 faces in a file and used it to train and test the neural network. This video is about how to take a data file like this and feed it into the program so that it can train the algorithm. I'll also talk about how we can be systematic about testing the algorithm to see how well it does using the data just from this file. So let's get started. Okay, so you can see I have all of the rows of my data, and I also have the emotion in this left-hand column. Now, let me show you just a little more about these numbers and where they come from. Now, when a person was loading the initial web page, like you can see over here with all the buttons, these sliders were hidden. But these sliders are controlling different parts of the face and are being randomly generated to try to give whoever is looking at the web page some different things to consider. So the position of the eyes, the angle of the eyes, the angle of the eyebrows, the length of the eyebrows, and so all of these things have different values. The CSV file has all of these numbers that represent the values of those different parameters for the face. And then in this last column, it has the emotion. So the goal is to train the machine learning algorithm to understand the relationship between all of these values and the emotion. Now this is a massive data set. There's over 850 rows to this data. I know that I want to use this data to train my algorithm, but I also want to be able to test it in a systematic way. There's a rule that many machine learning people follow, and that is that when you have a big data set like this, you take 80% of your data set and you use it for training, and you take the remaining 20% to test your algorithm after it's been trained to see how well it works. There are lots of ways to set up what is your training set and what is your data set. For me, I'm going to use a completely random way to take this data and split it into those two sets. So what I've done is I'm creating a random number in this cell. I'm then going to take the entire column of random numbers, which goes all the way down to the bottom of my data, I'm going to copy it, delete it, and then I'm going to paste it as values. The reason I do that is I want a bunch of random numbers here that I can use for sorting the data. Now I'm going to use a little trick to say that if that random number I've generated is greater than 0.8, I'm going to choose it as testing, and otherwise it's going to be training. And just from a probability standpoint, that there's a 20% probability that the number is going to be greater than 0.8. So if that's true, it's going to be testing, otherwise it's going to be training, and this should set up the right balance between the 80% training and 20% testing that I'm looking for. So I double click on this to fill that all the way down. And so now we can see that most of this is training, but there's also testing in there as well. All right, so now I'm going to insert a filter view. And I'm going to remove the testing checkmark so that I only see my training data. And I'm going to copy just the training data. And I'm going to paste only the values. So now you can see that I only have training data on this. And so this is going to be my training data, and I'll do it the same process for testing. So it looks good. Last thing, I'm going to delete these two columns from each of the pages. And so now I have my training sheet and I have my testing sheet, and I'm going to download both of these as what are called CSV files. I have these two separate files, and now it's time to load these into my training program. All right, so here we are. I have my program ready to go on P5.js, and I need to upload one of those data files that I just created. Now, I am logged in as me. You will probably have to make a copy of this file so that of this sketch so that you can upload your data file and do this yourself. So I'll go to this directory, upload file, and I'm going to grab the training data. That's this right here, face data training.csv, and upload it to the sketch. And I'm going to give it a better name, easier name. Just call it face data training.csv, and I'm going to add that for this input file as well. Okay. What this is going to do is this is going to load in that input file, and it's going to take all of the rows and it's going to load that data into the neural network. I'm going to show you very quickly. The inputs are those 1, 2, 3, 4, 5, 6, 7, 8, 9 parameters that we're going into generating the birds, so those are here. And also the outputs of a single string that is an emotion. And I am telling ML5.js that there are 9 inputs and 1 output, that this is a classification task because I'm taking a bunch of numbers and I want a label given to the output. And so these steps here load in the data. So the details of how it does this, it's a little hard to see because I tried to make my code pretty flexible, but what this is doing is this is creating for each row of that table, it's creating an input array of the first 9 values to match the inputs here, and then it creates an output array that is just the emotion, which you'll remember is the last column of my data. Okay, the rest of this I'm not going to explain. You can go through it, and this will be some of your adventure into using this, is kind of figuring out some of the details of how it works. I'm going to now train on this data, and I'll see you on the other side of the training process. Okay, training complete. You can see my little graph here, and the loss, as it gets better and better at understanding the numbers, kind of stabilized. I probably didn't need to train quite this long, but I did. I gave it that much time. Let's hide this now. And you can now see that this is doing what you saw before. Based on that data, it is classifying each version of the face, each random one that comes up, as one of those possible emotions. So we have surprised, angry, another surprised, and neutral. So it's going through and doing its best to identify which emotion it is. And at the end of the training, it also saved the trained network to my computer. I'm going to take that trained network and I'm going to upload it to a testing sketch that I built. And let's see how well the test goes with our testing data that we separated from the original data set a little bit earlier. All right, so this is the testing sketch. There are 2 things that I need to upload. The first thing is I need to upload my training data. Oops, I mean my testing data. So I go to my testing CSV file, open it up, and now that's there. And now I'm going to rename this the same way I did the other one, face data testing. And I can go down here and change this to face data testing. The second thing that I want to do is I want to upload my trained network. You want to be very careful. You're going to delete. I usually like to delete all 3 files and the directory because I think it's faster. You don't have to do it this way, but this is just my way. And then you want to rename them to the default names which don't have that number in parentheses. You might get that because you already have done some training projects in your downloads directory, and this is how Chrome renames files when there is already one with the same name in the download directory. So we'll go to sketch.js, and everything should be ready to go. So what this program does is it goes through each row of the testing data, and it looks at what the data says for each row the face was classified as. So is it happy? Is it sad? It's going to, so if we look at this one, we know a human identified this as happy. The neural network is also going to have an opinion about what it actually is. So let's give the algorithm a chance to see what it thinks. It'll compare it with what humans actually thought in going through the data and give us some information so that we can decide how well the algorithm is working. One last thing that I have realized, this is not training, this should be testing, because that is the name of my CSV file. Let's now run the code and see what results. Okay, so it has given us some information. Let's look at the console and copy and paste this into our Google Sheet, where it's going to be easier to actually analyze what's going on. So I'm going to go into this, and I'm actually going to highlight this entire table, and I'm going to paste it into a new tab that I've created in my data that I'm calling the Confusion Matrix Sheet. So let's just paste it in. Now I'm going to clean this up a bit, add some labels, and help you understand what this means. Okay, so we're ready. This top part of the table represents when a human has actually identified a particular row in that table as being happy, surprised, neutral, and so on. So if we add up everything in this column, this means that there are 33 elements of our data that are classified as happy. And we can drag the corner and drag this all the way across to see how many of each type the human classified. So 15 were surprised, 45 were neutral, 37 angry, and so on. And then the rows here represent what the neural network classified a particular image as. So if I add up the elements here, we can see that the neural network thought that there were 8 happy faces in the data, and 51 angry, 38 neutral, and 80 surprised. So the neural network is labeling a lot of these images as 80, a lot of these images as surprised. Now the place we want to look first is the diagonals of this table. So I'm going to highlight those here. Now the reason I'm highlighting these in green is that these are the ones that the network and the humans agreed. These were the ones that the neural network got right. So we should be really excited about everything that's on this diagonal. So 4 out of 33, the network agreed with the human. 4 out of 33, not a great percentage, but surprise, 7 out of 15, 12 out of 45, 21 out of 37, not bad, 6 out of 19. So we can look at the diagonals to understand what the network is doing correctly. So this is really useful for knowing how well it's actually working. And we can calculate the percentages. We can do that right here in the spreadsheet if you want to get an even better idea of how well this is working. But everything else in this table is also really, really useful. For example, you notice that there were 19 faces that a human classified as happy, but the neural network, for whatever reason, found the pattern that these appeared surprised. If we look at the neutral faces, that the neural network was really identifying a lot of those neutral faces, meaning neutral, not happy, not sad, not angry, just regular. And the neural network pattern found that there were 19 of those actual neutral faces it said looked surprised. The neural network had 21 out of 37 correctly identified as angry, but it's also noticing that neutral were really angry. Like humans looked at those faces and saw that they were angry, but the network was actually identifying those as surprised and neutral. So this is a place where you can then stand back and start to think about what your next steps are, because you can say, I need to give my neural network more data about the differences between surprised, neutral, and angry, because that will help the network better understand. And I have to admit, I'm not super impressed with the ability of the network to understand happy faces, because who doesn't love being happy? Correctly teach this algorithm to identify the faces that are happy. So it might be useful in the next step of trying to do this to feed a whole bunch of just happy faces or not happy faces. So that might be my next step. But now that I have this data, now that I know all of this data, I can make some objective decisions about what comes next. And that's really exciting. It's a great opportunity to say, all right, now that I know how my neural network is working, let's see if I can get it to work even better. So I hope this helps you understand how we can objectively use some testing data to evaluate a neural network. I also hope you now see how you can go from an initial CSV file of data into a training and a testing set. And this is hopefully going to become part of your own neural network projects moving forward. See you next time.